So let me begin. Keeping in mind that there are non-Singapore teachers, so I beg indulgence to just share with everyone. This is the Singapore framework for 21CC and student outcomes. So right in the middle, the yellow circle, the heart of the the yellow circle right in the center are our core values, which include respect, responsibility, resilience, integrity, care, and harmony. In the outer pink circle, this circle is sometimes known as the Swiss roll, um, among the Singapore teachers, are social emotional competencies, or SELs, as you might use in your country. And in the outer orange circle are the three emerging 21st century competencies that we have identified: critical, adaptive, and inventive thinking, communication, collaboration, and information skills, civic, global, and cross-cultural literacy. And then right on the outside of it are the desired outcomes of education at Singapore. So that we hope that every child, every student is a confident person, a self-directed learner, an active contributor, and a concerned citizen. To give you a little bit of background, just now I hear the SST teacher also share that you have a one-to-one device program. So for the benefit of the teachers from the other countries, in Singapore, sometime back in 2020, the personalized digital learning program was launched. This was the speech made by the then Minister for Education. The idea is to use SLS, which I'll be introducing in this particular sharing, to enhance the learning. And his quote literally was something that, I kept in mind because I thought that was quite apt. Let the interaction, the discussion, and the thinking come to the fore, so that the teachers don't take such a big role, less of teacher-directed learning, but more of the student voice in their learning. What is the SLS? Aside from the SST teachers, for the other teachers, SLS is the acronym for what we call the Student Learning Space. It is our ministry's core platform for teaching and learning. In other words, NJC didn't develop it. All schools in Singapore, all government schools in Singapore have access to this. All students have an account on Student Learning Space. They can find modules to do their own learning independently. Teachers can create courses on the Student Learning Space for the teaching and learning. So in this afternoon session, this is what I'll be sharing with you. Something that underpins the changes in the learning activities that are designed for my students is the understanding that we now know from cognitive science about really what is effective learning. In a webinar that was I attended last year, this was what I thought. It's very short and succinct. Effective learning approaches require students to be actively engaged in the material. Right. So as I design my activity, one of the questions I have is, how can I get my students to really interact with the content? Besides just reading, right? Sometimes when students read, the eyeballs roll over the words, but they are not quite engaging with the content. How do we get the students to create connections, to make representations? If we have already given them the notes, how do we get our students to generate meaning from the content, to really demonstrate the learning, right? And then how do we design activities with some level of difficulty, not too difficult, but some level of difficulty that might make their learning a little bit more effortful, but are actually more effective in the longer term, right? As opposed to memorize this and make sure you can regurgitate this for your exam. chances are they will forget that after the exam. But how do we design our learning so that as they struggle with the learning, it might be something that it will stick with them for a longer time. So in our particular course, the high school course that I'm describing right now, I'm talking about a course for year 11, year 12 students. So that's equivalent to JC 1 and 2 in Singapore context. The age group of our students, it's from 17 to 18. So that's the particular age group that we are talking about. Aside from the content, one of the first things the students encounter as they join the course is we share this learning mastery with them, that we share with them, this is the learning circle that you need to go through for every single unit, that we demand that you come to the lesson having previewed the particular section that we are talking about, right? And then as you attend lessons, participate in the class discussion. So I'll be sharing with you how the platform leveraging on technology has enabled us to do this. Take notes, and then have that ability to self-assess with the help of success criteria. Have I understood what I am intended to understand for the learning outcomes that are spelled out in the exam syllabus? And then how do I round up the learning by reflecting on, so what has changed in my thinking as I complete the activities for that's designed in the course. So to begin, let me share with you, this is the design framework. For the Singapore teachers, it might be immediately usable. Just a question, do SST assess SLS as well, weighting?
Yes, we do use it. However, it's not
okay.
like totally compulsory lah. So it's
Sure.
yes.
Okay, I just want to check whether it is relevant. Otherwise, it's going to be, first and foremost, it's not a platform that the other country teachers can immediately port over. But as I share the various components, I would just list off 10 what are certain net tools that we are familiar with. So this is the design framework that we have adopted for our units. All of our lessons are facilitated using technology. Very, very long ago, we have a lecture tutorial system in Singapore, but for maybe about 6 years or so now, for the learning for biology, we have moved away from lecture tutorial. Instead, we have a small class-based lesson, and then it is facilitated with the help of technology. So every topic has a single course. So whatever learning platform you think of and you use, all of our units are hung on the same course as it is, same platform, SLS. And then we have our sections that are tagged to the respective section of the notes. And then you have the third column here, which is the activity. So within this activity, there are two mainstays. The first mainstay, it's the pre-seminar task that we want the students to come into lesson with some sort of preparation. They will need to complete the encode part of this task. Basically, if you have read your notes, in your own words, can you describe what was the most challenging idea you understood? In a while, I'll share with you a video screen capture of what it looks like so that you have an idea. And then the practice makes progress for Singapore teachers, and I imagine for other school teachers as well, are really exam type questions. So we have picked up the ones that are relevant for each learning outcome. Each section usually revolves around one or two learning outcomes. And then the exit pass features a self-assessment tool where the students takes the initiative to reflect, okay, I'm confident of this learning outcome. And then they reflect on what is the one idea that I've understood better. So from the exit pass, they will go back to the recode section and complete that. So this is what it looks like for the pre-seminar, for the how we built in the self-directed learners. Hang on, let me check because the screen looks okay. Let me okay, here. Let me go back. This is the thing. All right. So we talk about one of the desired outcome is self-directed learners, and how do we facilitate that. So let me show a screen cap of what it looks like on our platform. So this screen video actually better illustrates the development of communication skills rather than the self-directed learners. What we have here is, if you look at this, this is an illustration. Earlier on, if you recall, effective learning approaches, one of it is generative learning. And for biology teachers, there are two biology colleagues here. One of the things that we would identify with is there is a lot of demand on visual literacy where biology is concerned. If we look into a research paper, these diagrams that we see above here are very typical. So a task that we get our students to do is this will open up a discussion where students will first discuss with their peers what are the key responses in the three tissues. So what the students need to do, if I go back a little bit on this video, am I able to return the video? Okay, I paused here. So this is about interpreting information. This is a self-signaling pathway. So the students would then put in what they understood of it, how they make sense of the arrows leading from one protein to another protein, and they will put in the discussions here. This is a built-in discussion board for other country teachers. We could do something like this using Padlet. Padlet is something that all of us are fairly familiar with. What if you noted one of the tasks in the pre-seminar task is for them to encode, which is they write a summary of what they understood in 2 or 3 sentences. Decode is a section where we encourage the students to ask questions that they have about the section. For example, in the topic of, this is a topic on cell cycle, students might ask questions like, where does cohesin come from? Why, how do the spindle fibers automatically disappear? These questions they have from reading. So we build the students, we enable our students to have that habit of asking questions about what they read. I will be upfront here. A class of 25 students, I don't have 25 students asking 25 questions. I have a handful of students asking questions, which as a teacher is very informative, because then I will go into class instead of teaching everything, I would respond specifically to the questions that have been identified by the students as illustrated by these questions. In the slide with the cognitive science, one of the things that was highlighted was active learning. How do we get our students to really interact with the content? Perhaps many of us, especially if we are science teachers here, can identify with the concept of modeling, right? Gilbert identified there are 5 modes of representing models: a concrete model, verbal model, symbolic models, visual model, and gestural. Gestural is like using hand actions. maybe not so relevant for my biology subject, but I think physics, we have your left hand and right hand rule as much as I remember of it. So with this in mind, some of the activities that we plan require the students to model the idea. So let me share with you. This is what the activity looks like. It has no audio. So let me just walk you through the screen capture. Um, okay, yeah, the video is playing. So we give them a visual representation. And then they play with the physical model. Very often we see this image in our notes, right? This platform allows us to embed videos, and then this is what they need to do. So within a small group, we want them to build a model, right? So they see on the diagram. Of course, you have diagrams that can show a 3D view, but we require the students to build that physical model. And then this is what a group work looks like. So one of the 21st century competency that we talk about is communication skills, right? So using this, the students then need to describe what is the model that they have built. So the audio, I hope you can hear the audio. The audio that you hear is actually the student describing the model that the group has made. Oh, can you hear the audio? Oh, whoops. Okay, okay. All right. I apologize. I think when I share the slides, I didn't share the audio. So this one, not only they built, I want them to, you might say, actually they were following the video that the YouTube had. They are following the steps that is shown in the image. But I believe there is value in really saying out as they twist the model from a linear into a ring form. And I think that gives them a deeper understanding of the model. So that's individual group work. Other groups, they don't necessarily put in the video. Some of them, they do an animation instead. So this thing has no audio. And then she took pictures and she used one of the app that's readily available. And then you see that little finger. And that's their way of communicating. So the task was to build alpha glucose and beta glucose. And then we extend to this, right? And we want, one of the most powerful thing, if students really understand, is to be able to identify errors in the model, right? So here is where when they post the pictures or they post the videos, you can then give feedback and say, the photo, it's not a correct glucose molecule that we are looking at. Why is that so? And then with the interaction, the consultation with the visual representation, they then identify that, okay, because the hydrogen and the hydroxyl groups are in the opposite positions. And that is very important in the understanding of the alpha glucose model and the beta glucose model. We go on to get our students to reflect how has the model building helped in their understanding, right? So we don't want students in the first iteration of this, we finish with the models and we don't stop to get the students to think about what they have done. In the second iteration, I started to put in questions like this. So how has this exercise helped in your understanding? And this is, what happened to the comments? Uh, oh, okay. So this is a comment that is made by the students. So it allows them to visualize the structure of the different polysaccharides. So that was a single unit. So that's a monosaccharide that we are talking about. My slides have jumbled a little bit. Then from a single group work, we now group the entire class together. So this is a whole class effort. So in a class, I have about 8 groups. 4 groups were building alpha glucose, another 4 groups were building beta glucose. And one of the things is they are obliged to remember, oh, has a helical structure, the other one has a planar structure. My belief is seeing, handling, it's always a lot more convincing. Right. And then what we did was we borrowed, can we have somebody to volunteer some pieces of paper? And when we rolled it up and we put it in the middle of the ring, it was a very visual thing for the students. They recognize that what is shown in the lower picture is the beta glucose as they polymerize. And the upper picture is the alpha glucose as they polymerize. They realize that with that particular conformation, it cannot be planar. So that's what they experienced with. And then this was the reflection at the end of the process of building a monosaccharide, a disaccharide, and then building it up to a polysaccharide. Yet in another unit on proteins, we adopted, we borrowed the idea. So my colleague designed this lesson. We borrowed the idea from a paper that was published. It's quite simply called the protein origami. And this is what the students do, right? So it's really quite straightforward. You print it out and then it's given to the students. Um, this student, you can see the picture in the notes, right? It's a very nice visual representation, but they can some students have difficulty trying to see it in a three-dimensional way. So the alpha helix model has it in a tube, and then we got the students to put in where the peptide bonds are going to be, so where the chemical bonds are going to be, and then we did a reverse engineering and we get them to cut it up. And as they unrolled it, they see that it is in sequence of the amino acid. This activity, if you'd like, I can share with you because we don't own this. It is borrowed from one of the paper that was published. So from an alpha helix, the other thing is all textbooks likes to publish the alpha helix structure separately from the beta pleated sheets. And then students will have this idea, oh, okay, they are either alpha helix or they are beta pleated sheet. It is not easy for them to put together how it looks like. So from a group work on single alpha helices, beta pleated sheets, they then come together again as a whole class. So there's the element of collaborating as a class, right? When I put all of the units together, aside from alpha helical motifs and beta pleated motifs, I actually have, as represented by the red string in this image, protein segments of the peptide that don't adopt a particular conformation, right? And that's represented. And then this builds up a protein as it is. And that's what that's an illustration of how we get our students to be actively engaged in their learning. And then this is the reflection that they had. For example, like how the connection of the red thread differs from the parallel to anti-parallel. That's a very, very technical thing for biology, so I will not belabor that point. Uh, Aside from modeling, what else can we do? We saw this video earlier because it's wrongly placed. Here, in as I mentioned earlier, in making sense of the graphic, right? That's information skills that we talk about. That's a very important thing in terms of the 21cc that we talked about, right? So aside from modeling, you have discussions. So very often in our lessons, I don't form much of the time. I don't. If I'm talking in class, it's in response to the questions that they have. It's in response to the posts that they made on the discussion boards, as opposed to a very classic I am delivering the content right in front of the classroom. So moving on, I would like to share how we have adopted and been using technology in practical lessons. So this really, it's a very, very new prototype. I'm mindful of the time. So some of us are familiar with the SAM-R technology integration model. Some of us are familiar with the RIT technological integration model. ETD, which is the EdTech division with the Ministry of Education in Singapore, adopts the RED model. So there were several considerations that I had in mind when I pivoted from a typical paper and pen practical, workbook into a tech-enabled practical workbook. So at a replacement level, we have used technology to reduce marking load for teachers, which is very, very important. So instead of marking everything and then collecting a very big stack of papers, we only uh, take out certain segments that we really want teacher marking. So other questions we have leveraged on the AI, the auto marking function of SLS to provide instant feedback, which is really, really wonderful in this in this time of day. Then we use technology to foster student collaboration. We have seen how collaboration takes place in the classroom learning, but collaboration is also possible even if I am delivering the content for a A-level subject that we are talking about. And how we can build in elements to facilitate self-directed learning. And better still, how we can leverage on technology to foster digital literacy. How do we make sense of data? How do we analyze and present data? So in this audio, there's audio attached to this, but maybe I'll just play and then I will do a mouth over instead of depending on the audio. So this is what it looks like in our digital practical workbook. Every activity that you see on the left-hand side is one practical lesson. And then never mind the A and B, actually, they are just referring to last year's practical or this year's practicals. So this is what one practical looks like. And I will explain to you why I titled this as Embracing the Idea that Science is Evidence-Based. So this is an enzyme practical, so chemistry teachers might also be familiar. All right. So here this is the sitting plan. Because collaboration is needed, I needed to spell out, okay, you are this group. This is to facilitate the entry of the data in a big spreadsheet later. This is typical instruction instead of on a paper and pen. This really is just a replacement. I've just switched it over to a digital form. Oh, whoops, it has gone all the way back. Right. So if you saw there were three things, A, B, C, doesn't matter. We don't need to go into the specific of context. So you saw that the students were grouped. There are three members in a group. Then they are supposed to work, and each one, aside from carrying out a basic thing, they needed to investigate what's the effect of A, B, C, and then they come together to put in their data. All right. And then let's move on. They are required to enter their data in a Google Sheet. Right? Everyone, I think in this time and age, we have access to Google Sheet. So instead of just a single practical sheet that records my own data, now actually I have access to everybody's data in the class. And we want to use the whole class data because that really shows the variability in the experiment and why in science it is very important for us to make repeats because they will see for themselves as they enter the data that the data points they collect is very variable. All right. And here, this is what they will look like. So we give very specific instructions to tell them, okay, you need to take the mean. And then after that, you will use the chart function and try to model what the results look like. There's no audio here, so I'm just going to direct your attention to the color. So this is the data for one class. If you observe the color is the same for the different classes, but the position of the color of the graphs will differ. So in this particular class data, the red is on top, red, green, blue, yellow. So I'm going to drag the video over to another class data. Red, green, blue, yellow. And then if you look at another class data, it is now red, yellow, blue, green. Right. So the idea is it requires a little bit of a mind shift in both teachers and students. Many of us are perhaps educated in a scenario where there's supposed to be a one model answer. What's the model answer? But in this particular task, A, B, C are unknown. Of course, the teachers, we know it, but we agree to facilitate our class discussion such that we don't reveal the exact identity of A, B, and C, but we want the students to discuss as a class based on the graph modeling, what matches their understanding of A, B, and C. So the concept here we are talking about is enzyme inhibition. Right. So very briefly, you have competitive inhibitor, you have non-competitive inhibitor, and one of them is not an inhibitor. So based on the graph, they are supposed to identify um, and explain which is most likely to be which for example, whether A is most likely to be an inhibitor or non-inhibitor. If it is an inhibitor, why, what type of inhibitor it is. So this is how we get use technology to get students to put in their data, and then the students are able to analyze a whole class data, so they also develop their digital literacy along the way in a science lesson. Let's move on to another example. Technology has also enabled us to adopt jigsaw learning in science practicals. Again, the audio has failed me, so I'm going to drag you through the video. All right, so this time round, we are talking about photosynthesis. I imagine that's a concept that many of us can connect with, except the depth of learning is different. All right, so in this particular practical, the students have a task that they all need to carry out. And then there is an optional task. So general instructions, the materials are listed for them. And then this is where opportunities for self-directed learning. Often in science practical, we will demonstrate in front of the class. And then the students standing in front of you can see the demonstration well. The students who are slightly behind, either they get distracted or they don't observe. Or sometimes I wonder if you have that experience, you are demonstrating, but the students end up not following whatever you have demonstrated. So what I've done here, and taking into consideration a student comment made some years ago, they asked, Miss Lee, it's useful if you make the video from the doing angle, right? When a student watches you doing demonstration, they need to do like that mirror, that mental mirror image, right? So what I've done is I have, for certain instructions where it is challenging, I've recorded the video so the students can watch at their own pace at different times within the practical. So where's the jigsaw learning? The jigsaw learning comes here. They either do a part 2 or 3. One is about investigating the concentration of carbon dioxide for photosynthesis. The other independent variable is investigating the effect of different wavelengths for photosynthesis. So this is what the practical setup is like, right? So one half of the class does one, the other half of the class do another one. And then because all of these results are posted in the discussion board, the whole class then gets to learn together without having to take 2 sessions of practical. So this is what it looks like. You see the devices. It can be laptops. It can be the iPads. They are fairly comfortable with making space for their devices. There are occasions when we do have fire listed on the Bunsen burner. Nobody has burned down their device yet. Of course, maybe the chemistry teacher was saying, what if I have the burettes and the pipettes and everything? But so far, it is manageable within a very standard lab setting in a Singapore lab. We talk about one of the things we hope is how can we build in that sort of reflective practice. For certain practicals, you might have the experience that there are certain instructions where the students would have very variable approaches to carrying it out. So here I demonstrated one set of instruction, but there are 2 ways of setting up the experiment as demonstrated by the student example here. So the task is quite simply to take a picture of their setup, post it on the discussion board. Then after the practical lesson back in the classroom, we discuss what are the merits of these 2 setups. And then we get the students to reflect on if they were to make improvements, what would they do, right? So you see in the post that's at the site, this is where the students will then, for improvement, instead of taking it from the base, try to make sure they receive all equal intensity. These things are not possible if I don't even capture the digital artifact. So I know I have overrun, but that pretty much wraps up the sharing I have on how we have used technology to kind of foster 21cc competencies in biology lessons. So thank you very much for listening and staying online. If you have any questions, I'll be happy to answer. And I left my email there. So if you like to somehow observe the lesson digitally, write in and let me know. Somebody has a question raised.
Yes, thank you very much for very wonderful presentation and practical activity. I wonder that what is the which is the platform that you use? Is it a private or public platform
This is a
or created?
MOE platform that I've introduced right at the start.
Oh, MOE.
Yeah.
It
So
is used just only for the Singapore NJC, right?
Singapore schools, all Singapore schools have this.
Mm.
If you think about it, right, it will be if you imagine Apple Classroom, that's what's that thing? Apple has is it Apple University where you can create modules? I know that in Singapore, some schools who adopt Apple, they have that Apple University and the teachers create modules on it. Another way of thinking about it is if you think about all the open learning platforms like Coursera, but it's just that our ministry, for the benefit of learning of students in Singapore, they have developed this in-house teaching and learning platform. So that is able to do auto marking, which I didn't feature, but it has the discussion board function, which many of us would use, like with Padlet as a very, very good example. Or it can post like discussion forum, which is possible on Google Classroom. Yeah.
Thank you very much.
はい。
So you have the starter, like with all the learning material in here, but you also has the freedom to adjust some content, right?
Yes, because the platform is really just a platform where we use to create our courses. So this is really a practitioner sharing on how I have exploited the platform to create the courses for our students. Maybe if I stop share and I share what it looks like live for the platform. Let me see if I share the window, whether I have one. Okay. Do you see the screen? I don't know what am I sharing. Oh, okay. I'm sharing the screen here. So this is the platform. Let me exit and show you what a classroom looks like. So this is the entry page. So I forgot what is the version that Apple has. That Apple University, if you enter, this is each class that we have. So we have 6 classes of biology at high school level, senior high school level. And then when you go into the class, this is what I mean by every topic has one course. And then say, for example, the practical that I was sharing, this is the practical workbook that they have. So this helps to prepare them for examination, right? So every practical is one activity. If we are talking about a classroom lesson, for example, just now I shared on cell cycle. So this is the real model of a pre-seminar task. We break down the reading that they need to do because we are mindful of the time spent on homework. Then we leverage on resources that are open source, right? Like YouTube. There are lots of learning videos that we can have. And then this is the task that they need to do in their own words. What's the most challenging idea? It gives information to the teacher what the students find difficult and whether they understood correctly what they thought they understood. Yeah.
I heard from the news that the Singapore school not allow students to use smartphone in class. So on what device that they use for access this lesson?
Okay. Um, the tightening on the use of smartphones applies particularly for the secondary students, right? And then even so never mind about primary school students. But earlier on, I introduced the thing called personalized digital learning program. So that program is developed to the end goal of that program is every child has a learning device. So smartphone is not usable in the classroom, but your learning device is permitted because the learning device has a management system on it that prevents you from accessing certain things. Yeah. So not using handphones, but either iPads, Chromebooks, or laptops. Yeah.
So it's not the personal iPad that they can install everything, but it's the school iPad that get like some social media lock and not accessible during the class, thing like that.
For the senior high, for the grades 11 and 12, we are not too fixated on whether it's the school. There's no school locking on 17-year-olds and 18-year-olds. But if you ask a real question, do they sometimes switch on to their social media or, they are chatting like WhatsApp? We are familiar with WhatsApp. We all have in the WhatsApp group at ISSF last year, right? The students will toggle over. But when the lesson is developed in such a way, or when the lesson is designed in such a way, actually the time is taken up. They don't have that much free time. And because it's a fairly big device, as you walk around, you can tell who just switched over to something. So personal messaging occurs, but gaming at the same time in a lesson, no, that doesn't happen, because the learning they need to acquire demands their attention that they don't have time to go into the gaming and whatnot. Any other
One more
questions?
question for
Yes.
the preview. Do you still use the normal textbook or do they read the content from their learning device?
We don't have textbooks for senior high. So let me share the window again. Okay, here, cell cycle. So at the introduction part, the notes is uploaded here. So the students will download the soft copy, and then they will annotate on their own notes. Yeah, so there isn't a single textbook for senior high. At least not for my subject. Okay. Well, it's nice to see many teachers from different countries today. I was wondering, I'm only one presenter, and if there will be any audience today. But thank you for coming on. I left my email on the screen just now. If you like to keep in contact, please email me, right? And then so that we can learn from each other.
Jen, is it 4 in the morning as always?
Yeah,
Three,
yeah,
three.
it's 3:30 right now. Yeah.
Yeah. Because when she came on, she said it was 2:30.
Yeah. But it's so nice to see everyone. So
Yes.
it's worth getting up.
Yes.
Hi,
Thank
Kylie.
you.
Yeah.
Oh, yes, from Australia. Oh, what time is
Yeah.
it now? 6 p.m.?
At 7 p.m. for us.
7 p.m. Wow.
Oh, one more
From
question.
yes.
Since you have so many reflection from student like video or their comment uh in the system, do they have like automatic analysis that like grouping the answer or grading the answer for you, or does the teacher have to still do it like manually for each student?
Okay, so I'm going to just demonstrate the power of artificial intelligence. I didn't create it. It was courtesy of the ministry who spent a lot of money doing this. So let's look at this. This is our typical exam question. Very normal, right? So one of the things that we can do is this tab here allows me to monitor who has done the homework and who hasn't. So in non-tech enabled, I would have to go around and walk and identify which students did the work and didn't. When the questions are tagged to the marks, the system is enabled to identify. So the green ones are the ones who get all correct for the marks allocated. Pink is maybe half the marks, and then red is less than half the marks, that sort of thing. So at a quick glance, you can tell, okay, I don't need to spend time talking about question 3 and 4, but maybe I need to spend time talking about question 6. So that's a very simplistic level. Here, so let me show you the response. We have auto marking, so that's the most useful function that any teacher can ask for. So this is how we have embedded the algorithm. Frames the answer this way. This is 1 mark, and this is the thing I'm looking out for. And then they will do auto marking. And the amazed question is, do I need to analyze this one by one? Because, scrolling down 25 students is going to be very time consuming. Yes, we have AI to identify specific responses or misconceptions. So if I click on this generate, it takes time, but it does a reasonable job up to now. The cat is kind of cute. Yeah. So this were identified based on the mark scheme that you've entered. What was the intended mark scheme? And then these are the things that they picked up. So within a classroom setting, the teachers appear to be very smart and very efficient in front of the students with the help of the auto marking function. Yeah. Okay. I am very, very mindful of time because I've managed to take up the entire hour all by myself. Right. Thank you, everyone, for coming on today. And then the lucky ones will see each other at the ISSF at the end of this year. I'm not the lucky one, but someone here will be the lucky one. Okay. Thank you very much. Bye-bye.
Thank you very much.
Thank you.
Thank you.
So
Bye.
jealous.